let us talk about strain gauge adhesive. Adhesive is a type of material used to bond the strain gauge to the test specimen. Its function is to convey the strength in the test specimen to the strain gauge. Adhesive is very important as it will directly affect the accuracy of the measurements of the strain gauge. It needs to be effectively conveying the strength from the test specimen to the strain gauge. As we cannot measure the test specimen directly, what we can do, we are measuring the strain gauge. Now, if the adhesive cannot function properly in conveying the strength, the measurements in terms of the strength of the test specimen will not be accurate. First, let us discuss about the strength conveyance mechanism. You have the sensitive materials here, which is laid at the utmost layer of the strain gauge. The sensitive element grids here sit on the gauge base. This gauge base serves as the base for the sensitive element grid to keep it in position, which at the same time serves as the insulator for electricity. It is especially when the test specimen here is an electric conductor. You don't want this to affect the accuracy in terms of the measurements of the strain gauge. Now, this grid and the gauge base here come together as a strain gauge. It is then attached to the test specimen by using the adhesive. Now, when the test specimen is subjected to load, strain develop within the test specimen. These deformations subsequently is being conveyed from the test specimen to the adhesive and then to the base and finally to the sensitive element grids in the strain gauge. The measurements is using the sensitive elements grid. Now, the characteristic required from the adhesive here, it will be the bond strength and also peel strength. The strength must be good enough to prevent the strain gauge from detaching from the test specimen. Also, the adhesive should convey the strength to the gauge base, but not to absorb the strength in the test specimen. Therefore, you cannot use anything other than the relevant adhesive to have the strain gauge stick to the test specimen. For example, double-sided adhesive tape for the domestic usage. This kind of adhesive tape can absorb the strength and may not have sufficient bond strength and peel strength to have the strain gauge attached to the test specimen. Now, if the strength cannot be effectively conveyed from the test specimen to the strain gauge, specifically conveying to the grid, now the measurement will not be accurate. You cannot simply use any ordinary adhesive for that reason. Also, the creep characteristic of the adhesive layer are crucial in preventing the adhesive from absorbing the strength, as well as accurately convey the strength to the strain gauge base. Therefore, for safe application, you should use the right adhesive purposely designed for the usage of the strain gauge. Now, let us look at the major properties required in strain gauge adhesive. First, it must have large elastic modulus and minimum change with temperature or humidity. In another word, it must have excellent creep characteristics. Elastic modulus is related to the ability to resist deformation. You do not wish to have relative differences in terms of the deformations undergone by the test specimen and the deformations experienced by the adhesive. If possible, the two deformations shall be equal and the differences shall be kept minimal. You also do not want the adhesive to have disturbed by the temperature and also the humidity. And you want excellent bond strength for the temperature, humidity, and the amount of strength. Even though undergo deformations, you need to ensure the adhesive still functioning well, keeping the strain gauge intact with the test specimen. Also, you want the adhesive to have good electrical insulation so that it doesn't conduct electricity that may affect the measurements of the changes in terms of the resistance in the strain gauge. We have various types of adhesive. We have cyanoacrylate, which is known as the CN type adhesive. We have polyester, we have epoxy, and we have phenol resin. The CN adhesive is the most widely used. Personally, I only have experience of using this CN adhesive. As for the others, I have no relevant experience. This CN adhesive is colorless, clean, non-solvent instant adhesive that dries at room temperature. The time required to install a strain gauge is very short, and this type of adhesive is easy to use. Basically, it extracts moisture in the air or on the surface of the test specimen to quickly polymerize and generate adhesive strength. Within a few seconds, the strain gauge is firmly attached to the test specimen by using this adhesive. For the adhesive to harden, it requires moisture. While using this adhesive, you need to be careful. Make sure you don't touch it with your finger. Your finger will be attached to each other when contact with this adhesive. There is quite a series of CN adhesive. The most common one is this. If not mistaken, this CN adhesive comes in 5 units per packet. Once it is open, it is considered exposed to the environment. You have to use up the entire unit of this adhesive. Over time, it will harden unless you are able to prevent the contact with the moisture. The second type is the polyester. It is made up of the main component and the hardening agent. It exhibits excellent resistance to moisture and chemical. Now the amount of hardening agents are added based on the intended setting type. You may adjust the hardening agent for different setting type. The stress now is less than epoxy adhesive, and it is normally used to install strain gauges on concrete and metal surface due to the creep characteristic and resistant to heat. Care must be taken to apply appropriate pressure during the application. We have P2, RP2, MP50, and PS. These photos are extracted from the catalog and the internet. This is P2, MP50B, PS, RP2. They look similar. Make sure you read the label before using it. Next one, it will be the epoxy. You have EA, 2A, and EB2. This one can be used with almost any testing material, as it ensures a good bond with most of the material. EA2A is used for low temperature, and EB2 is used for the long-term measurement application. The epoxy type of adhesive hardens at room temperature but it requires longer time, which is roughly about 24 hours to harden. Care must be taken to maintain the pressure during the installation, and theoretically, pressure should be applied throughout that 24 hours until it is fully hardened. Next, we have phenol resin. It is labeled as C1. It is a typical single component heat curing adhesive that have excellent adhesive strength and long-term stability. It is used for long-term measurements and in transducer. The meaning of long-term measurement is that you intend to monitor the conditions of your test specimen over time. Normally, the strain gauge will remain there. Over a period of time, you measure the strain gauge again, over and over again. Now you require the adhesive to be strong enough and last over a long period of time. Now the installations requires a heating unit capable of heating to 200 degrees Celsius and a clamping tool. I never used this before. However, based on the description here, it seems complicated. If you need to use this in your research study, make sure you flick through the guides for the proper procedures of using this adhesive. Now let us proceed with our discussion. In terms of selecting the adhesive, we know there are various types of adhesive. The question is, which type is suitable for your application? We will look into this in three main aspects. First one is the selection based on the gauge series. Second one is selection based on the specimen material. And the third one, it will be selection based on the operational temperature range. Now, knowing the purpose of the testing, going through the guides of selecting the strain gauge, the series of the strain gauge has been determined. Knowing what type of strain gauge is being used, by referring to the table here, you are able to determine the appropriate adhesive. In my case, I only use strain gauge for general purposes, doing some simple testing on concrete and steel. Very often, I use strain gauge F series, and I end up with CN adhesives. You may also use EB2 adhesive, which previously we mentioned. EB2 is meant for long-term measurement application. Depending on your research topic, are you going to do the long-term measurement? If not, you may use this CN adhesive. There are other series and their respective appropriate adhesive. It seems that CN adhesives is quite popular and can be used in most of the series. If you are not sure, most likely CN will be applicable. You may always check with the catalog as well as the guideline for the strain gauge. Next, you may select the adhesive based on the specimen material. If you deal with metal, these are the list of appropriate adhesive: plastic, composite, woods or gypsum, concrete or mortar. Again, you see CN is also quite popular, which can be used nearly for all types of material. You may refer to the table here to determine the suitable material used for different types of specimen. It seems that woods or gypsum or concrete or mortar will require CNE instead of CN. The packet looks the same, but the names is different. Based on the bottle here, the cap of the bottle has different color. You need to be able to differentiate them. Next is the selection based on the operational temperature range. These are the series of adhesive. as well as the applicable range for the adhesive. For C adhesive, it is ranging between -30 degrees Celsius to 120 degrees Celsius. This is for normal usage.